Hello. So we're here with a new file. I'm going to open up some old code and I want to go ahead and read this program with you. And we'll do our best with it. Alright. So this here is a program which, given a height and a radius, will go ahead and calculate the surface area of a cone. Decently useful. If I were to go and put in 2 and 0.6, I'm going to get this value. I want you to understand that I'm using this as my value for pi. Not exactly accurate, but I don't really care. If we were pretending that that were accurate, you'll notice that that is an accurate number. Because if I were to take 2 times 2 plus, uh, plus 0.6 times 0.6, because the formula is actually like this. Surface area of the cone is height squared plus radius squared plus radius and all that times the radius times pi, which we're pretending is that number right there. And that comes out to that number. You can see that our program works just fine, even with its bad pi value. So what I'm going to do is I'm going to take this code out of here. We're going to ignore this while loop for a moment. Actually, for the whole lesson, we're not going to deal with the while loop at all. But I'll put up a new file and just kind of copy that code in there. Take out some of these spaces because it will actually literally not work if I don't. Day 1, dash 2. Right. So let's go and take a look at what we have here. We have a program which, given a height of a cone and a radius, gives us the surface area. And that's a really big cone right there. Actually, that's a very fat cone. It's very short, but very fat cone. It's 24-inch diameter, 4 inches tall. That's a weird cone. Anyways, let's go ahead and jump right into it. All right, so far you've gotten the definition of print, I'm hoping. Which means print to screen. That code prints a screen, takes digital data, and makes it visible. Because if I don't print, because I can have as many variables as I want in my program, but unless I print them out, no one's going to see them. Alright, so printing I'm hoping you got, but now let's talk about this input line. And I'm going to actually just retype the whole thing because I want to start it over from scratch. So I'm going to make a new variable called h. H is going to hold the height. In fact, I'm going to make this even, no, actually I'm going to keep it as this. H is going to hold the height. Now, in order to read in from the user, I'm going to use the input command. Input is something where I can actually print a message to the user, such as please input the height of your cone, and the user is going to see that message and be able to write back into it. And let's go and print out h, so that way we can see that it works. So if I were to give it, 17 as the height of the cone, you can see that right there. Cool. So let's keep going. Something that's kind of unfortunate about input, which again, input is the code command for taking from the user and saving data digitally. So whatever the user types in, it saves into this h here. What you'll notice is R for radius has a similar thing, but it also has this part here, float. And that float code kind of looks like the str from earlier. And that's because it's very much like it. Understand this. Input by default, input by default reads in a string. Input reads as string. And when we later go into this, we don't really like for our h, for our height, to be in a string value, because there actually is a lot of difference between the number 2 as a character and the number 2 as a letter. I'm sorry, as a value. And that might not make a lot of sense if you've never seen this before. I'm not talking about the random adds on the side, I'm talking about the ASCII table. ASCII is a code standard for showing data on the computer. You see, here's the thing. When you have a computer, it deals with ones and zeros, as you've probably been aware of. Even if you don't understand how exactly, you understand at least that computers use ones and zeros. What you should understand is that number system is called binary, and those binary values can actually have decimal representations. Decimal as in the decimal number system, the one that you and I are most familiar with. You can see this number system here. Even though no binary values are included, you don't see 101 or 101. I will tell you that each of these do have a binary equivalent. For instance, 5 over here is 101, or 8 here is 1000. Well, let's talk about this then. Look at the number 2 here, the character 2. This is, in red, the character 2. And red is just simply to identify it here on the page. It doesn't show up red or anything. When we read in 2 as a string, it's actually the number 50 behind the scenes, but written as, this number right here, 110010. What we really want is the number 2, not the number 50, but the number 2, or 10. So we want this number, and so what we have to do is we can't leave it as a string, because right now it is technically a string. Input defaults as string. We have to turn it into a number, and that's what we do when we put that float code in there, and then wrap its parentheses around whatever data is here. So we read into as a string at first, but then we transform it into the number 2. It will transform into the number 2 instead of the number 50. And of course, so if I were to print it out, you see it comes out as 2. 2.0 technically, but let's not worry about that just yet. Alright, so let's keep going. Hopefully you got it. And we'll change our message here for radius so that it's more user-friendly. When I first wrote this program, it was really just for testing student work, and so it didn't really need to be user-friendly because I knew how it worked. And now I'm going to go ahead and run it, and we're going to see our first error. So I'm going to expand this window because this is abysmal to read. All right. So please input the height of our phone. Okay. Well, I remember from earlier when I gave it 2 and 0.6, I got this 9.35 number. So let's try those again. 2, 0.6, and break. Now why? Well, whenever you see these red messages, this is called an error. Errors happen when we don't type in code correctly. So let's figure out why. I said the variable a, which is a new variable we just make up here, equals pi times radius plus height squared plus radius squared. Yes, I'm going to explain what this part and this part means in just a moment. But first, let's go and take a look at this error. It says h, our height, is not defined. Meaning, whenever you see that, that means that that variable doesn't really exist yet. Which is odd, because isn't that it? Well, technically not. H and h are not the same, but h and h are. When we deal with this, this does need to be in the proper case, as in lowercase and uppercase. Otherwise, it will crash. It does not understand that h and h were supposed to be the same. We had to make them exactly the same. And in that same vein, I'm going to go and change a to SA. That doesn't do anything differently in the execution of the code, but I think it's a much better variable name, because my variable name should be descriptive, and A is just area, but SA would be surface area. So while it doesn't make any difference to the computer, It makes a difference to me, the program, so I can better understand what I'm doing. Now, for you to better understand what I'm doing, here's a couple more code definitions for you. This asterisk here is times. 2 asterisks, however, is exponent. So this line can also be written as surface area equals pi times radius plus height squared plus radius squared. And right there, that is exactly what we see there. Actually, just times. There you go. So there it is in Python, there it is in English. That's how we can make a nice working application for math. Hopefully you have some ideas of where else you can take that. I'd love to see what you do. Best of luck, and I think that's going to go ahead and wrap us up for today. All right, see you next time.